Hello, we are going to study the rotational inertia of different shapes of objects. First, we are going to use a disk. It's a solid object, okay? And then we are going to use a ring, a hollow object. It's solid on the outside, but there is a big hole in the center. And finally, we are going to use two masses, mass 1 and mass 2, which is mounted or installed on a rod which is very light compared to the masses. It's called the mass and rod system. We will begin by calculating the theoretical value of the inertia of our three objects, the disk, the ring, and the masses. Next, we are going to subject our three different shapes by applying a torque which will cause them to rotate. And the computer, with the help of the Data Studio software, is going to measure the angular velocity versus time from which we can calculate the inertia of each object experimentally. The torque is calculated by taking the radius of this pulley, okay, by which we apply a force which is equivalent to 25 grams. Once our setup is ready, we will first start with the disc. Install the disc on top of the pulley, and with the help of a screw, tighten to make sure that the disc is not going to wobble or fall. Next, wind your pulley, okay, and hold it in place. Now, some precautions. Make sure that the mass, which is going to apply with gravity the torque, is not swinging. It has to be steady. Secondly, the string. I don't know if you can see it from the video, but there is a string here, okay, right over here, must be horizontal. It should not be going too high or too low. You can do that by adjusting this pulley here, this high, this is low, okay, but make sure that it is horizontal. And finally, you also set the pulley slightly angled to one side so that the string is tangent to your three-step pulley, which is on top of the rotational motion sensor, which is this one, okay? Click Start from the software and then Release. Now, what you notice is that, let's stop first. In the graph is going down. What does that mean? That the direction of your rotation is going in the opposite. What you can do is you can take the rotary motion sensor, which is plugged to our interface, and reverse the polarity from there. Or you can take your pulley and angle it to the opposite side. Finally, you will wind the string again, this time in the opposite direction, to make sure that your graph is positive. This is what you do if the graph goes down instead of up. If you want to remove the data, just go to Data and then No Data, or you can completely erase it. But be careful that you will not erase it all the data, okay? So just delete the last data run. Let's try it again. Click Start and then Release. Okay, and then stop. Once you have your graph, we are interested in the straight line portion of the graph with a positive slope. You will highlight this graph, and just like before, you will click Fit and Linear Fit to get the slope of the graph. The slope is, of course, the first number. Once you finish, then it's time to calculate the inertia of the disk using the experimental method. with the slope. After that, we will go with the ring. Now, you cannot install the ring onto our rotational motion sensor because there is nowhere to fix our ring. So instead, we will use the disc and place the ring on top. Now you will notice that at the top of the disc, there are two holes, this one and this one here. On your ring, there are two bumps. You have to align them, make sure that each bump will go inside the hole of the ring, of the disc, sorry. And from there, the ring can be rotated and the rotation will be more stable because they are attached together. Again, you can wind the string around the pulley, hold it in place. You can hide the original data from the ring by going Data, No Data, and finally click Start and Release. There you go. Make sure that you click Stop once the graph starts to go down. Again, we are interested in the straight line portion of the graph. Select that line, go with Fit, Linear Fit, and you have the second slope. That is the slope of the inertia for the ring. But you have to take note that you are actually measuring the angular acceleration, radian per second, of the ring and the disk together. So that when you calculate the final inertia, you have to minus the inertia of the disk. Finally, again, you will do the theoretical value to calculate the inertia of the mass and rod system. And once you do, you will take your mass and rod and the screw which we use to attach the objects into our rotary motion sensor. You will take the screw and install it in your mass and rod first. And once that is done, you may now install it on top of your rotary motion sensor. Just make sure that your masses are exactly at the end here, okay, here and here at the end of your rod. Next, wind the string around the pulley. Okay, you can do like this. Hold the mass in place. Make sure that the hanging mass is not, this one here, is not swinging. Let's hide the data from the previous run. Click Start and Release. And stop. Now, make sure that when you are doing the experiment, you try to not bring your face very close to the rotating object so that you don't get injured. Once that is done, again, we select the positive slope of the line, the straight line portion. Go to Fit, Linear Fit, and that's your third slope. You can now calculate the inertia of the mass and rod using this slope. In order to put all three graphs together, what you can do is go to Data, select the first run, Fit, and then Linear Fit. Again, go to Data, select the second run, and go to Fit, Linear Fit. Once you have all three, just arrange the slope like this, okay? And you can take a screenshot of your data so that you can submit your graph or you can print it out.